In this presentation, I'll quickly run you through what a rapid industrial IoT application builder is. The approach around this is how can you very quickly build out in a lean way a minimum viable product where you can test hypothesis, because quite often we find this IoT thing is quite new for a lot of organizations. They don't really know how to start, they don't know where the ROI is going to be, and really it's a discovery kind of process. So using a lean approach where you start off with a minimum viable product, and what do we need to build out, what hypothesis do we need to test, how do we check that the data comes through. This can be done in XMPro in a very quick and easy visual way. And once you've found those use cases where there is ROI and there's a meaningful business case, you can then look at how do I scale this out to the enterprise. And all of this is just so that we can realize quick time to value and don't spend time and resources and money on things that don't work well. So when you look at XMPro, the typical, we call them mega use cases or big buckets of problems that we solve. Quite a lot of organizations are currently looking at how can we become smarter at our operations, and things like maintenance is quite at the forefront, but it's just one typical use case that sits inside this predictive operations. Operational intelligence, how do I make sure I'm not blindsided? How do I have this real-time situational awareness? In terms of operational excellence, again, safety, quality, asset integrity, key big buckets of problems that many of the customers are looking to address. Likewise with operational risk, how can we look at it from a loss prevention and tracking? How do we make sure that we know where risk events are and how we can potentially mitigate them? How can we run a digital business where we do digital transformation? How can we integrate different operations and have that visibility across them? And one of the key things that we quite often find is how can we respond to events quickly? How can we reduce the latency between when events happen and when we take action? And quite often that relates back to things like process health, where what is the overall status of the different areas of my business process, so that I have that awareness so that I can respond quickly to things that may impact my business. And lastly, one of the key things around running businesses these days is making sure that you have a good customer and employee experience, and again real-time responsiveness is becoming more and more a key part of that. So looking at XMPro, what is it? Well, it's essentially a model-driven application builder. By model-driven, we mean we can drag and drop blocks on here, and in a visual way we can construct what the problem is. What it does, it's essentially the software glue that connects real-time data sources to analytics, whether it's simple analytics or complex analytics. And then what we really want is actions that come out of the business. So how do we connect this to actions like work orders or any other business processes or even workflows that might be customized? And what it means for organizations that leverage this capability is that their subject matter experts, like the engineers, technicians, and architects, can create and deploy in a very agile way, as I mentioned earlier, from a lean approach perspective, in an agile way and in an iterative way, real-time IoT applications that can serve a range of different use cases. So it's not just a single problem that you can solve, but you can use this approach and reuse the blocks on here to address multiple challenges inside the business. And the whole objective is to do this with as little coding as possible, and most of it in the visual user interface that you see. So what does XMPro consist of? There are two main components. We talk about the Agile Design Studio, and this is typically where we design applications and components for that, and I'll show you an example of that. And then how do we deploy this in the action console where we take action. The best way to show you what that is and how it works is actually to do a quick demonstration. In the demonstration, I'll be talking about fin fans, and a fin fan, you can see the flatbed truck. This is typically the units that fit on top of a cooling tower in an industrial plant, typically used in mining, oil and gas, and energy and utilities, and a broad range of those industries. And again, if you look at the impact of this, if one of those fin fans fail, you have to shut down the whole cooling tower operation, which again quite often impacts the operations, and sometimes you have to even shut down your whole operations plant. Some customers run hundreds, some literally run thousands of these inside their organization. And if the bearings wear out and we have misalignment on any of these shafts here, the vibration on these fans will shake the whole building to parts. So let me quickly show you how we address this kind of problem inside XMPro. So this is a typical user interface for an engineer. This is called the XMPro Use Case Manager, and in here I can see multiple different use cases or problems that I'm trying to solve inside the business. So it might be anything from monitoring power and variable speed motors. It could be the fin fans, which we will discuss in this example. It could be vibration analysis, logistics deviation, failure of deliveries, pit access monitoring, and open pit mining, bearing failure. So as you can see, as an engineer, I can address multiple different business problems in the use case manager. So with the fin fans, those massive big fin fans on the top of the cooling tower, we'll start off with a very basic model, and quite often we find this is how customers go through the process as they get more sophisticated, as they get more data, and as they understand the problem that they're trying to solve much better. They will go through a more going from a basic model like we have here to a more advanced, which I will also show in this example. So before I go into the back end and how a lot of this is constructed, let me quickly run you through the logic of what we're seeing here. So we're going to get vibration and temperature, which is currently stored in a historian system, in this instance OSIsoft. So the vibration and the temperature on the shaft and bearing that hold that fin fan in place, and from the EAM system, the enterprise asset management, or the asset intelligence network, or depending on which system you use to store the make and model, for example, we'll get some information, some contextual information around the fin fan. In this instance, we want to know which make and model it is, so we can pass that together by combining it with to a machine learning model that will give us a prediction whether this fin fan is likely to fail. If it is likely to fail, we will just very simply create a work order. So a very simple model. Again, we take vibration and temperature data, we combine that with model and make and model information, run a machine learning model, get a prediction if this is going to fail, and if it's going to fail, create a work order inside the EAM system. Now the way that we bring information in, we have a concept of an extensible library. So this means we can extend the library, you can extend the library, or your systems integrator, for example, could extend the library of what we call listeners, or data sources where we can bring data from. This is a small subset of available listeners. Transformations, how can we change the information? Like you can see, we can combine the information, contextualize. Those are typically transformations that we can do. You can even run scripts there to do very specific data cleanup if the missing value substitutor, for example, doesn't address your specific requirement. Bringing in context, as I mentioned previously, we wanted to bring in the make and model from a certain for a certain piece of equipment. Again, extensible library concept, so very easy for us to add additional library components. We can add it, you can add it, and your systems integrator can also add it. Action agents, this is what at the end here, what do we want it to do? So action agents, again, broad range of action agents built on the exact same extensible library construct, so that you can add new or specific applications that you may have in your business where you want to send the data to. And then lastly, statistical and other mathematical functions, for example, doing fast Fourier transformations, running R scripts from an analytics perspective. If you have your own algorithms, all of these are available as drag and drop items. Once I've dragged the item on, I can configure the properties. So what you'll see in this instance with this OSI example, this is the OSI server setup. So and this actually looks at the asset framework structure that is inside OSI soft. So it will expose all the properties and values of the underlying services that it connects. What we're doing here is we because it's not a real-time streaming data source, which we would cater for in here by having a channel to push it to, we have to pull the data. We do it every 10 seconds, and we do it based on the specific asset framework where we're looking for the information. So very easy for an engineer or a subject matter expert to construct these once the blocks are deployed, and this is typically done within the IT organization to ensure governance, access controls, and security, everything that we need around IT governance. And once it is available and published, it then becomes an object that an engineer or someone like that can drag on. Let's step onto a little bit more of a sophisticated example of FinFan. So very basic, very simple, but you can see how we can monitor real time for certain conditions. I'm going to jump right to the extended model, skipping the one in the middle. And in this extended model, it is essentially exactly the same process. We're reading data, vibration and temperature. From here, we're bringing in information, make and model from the manufacturer. Here we run that exact same predictive model to see if it's likely to fail. If it is likely to fail, we want to take certain actions. So we want to publish to a dashboard, we want to send out a SMS, and we want to, in the XMPro action management side of things, want to create failure mode analysis, root cause analysis, push it to visualization dashboards. What we also do with the same data, so by broadcasting the data over here and broadcasting it over here, we can now call a second predictive model. Now that we know it is likely to fail, we can call a second predictive model, which will give us remaining useful life. So say, for example, in this instance, we get a remaining useful life of 100 hours. It means we have a window of opportunity to maintain that piece of equipment within 100 hours. The challenge with that is where in the 100 hours is the best time to do that. And with XMPro, as you can see, you can chain multiple algorithms and logical components and analytics together. So by chaining, is it a first predictive model, a second predictive model, and a third optimization model, where this one will look at production schedules, at customer orders, at maintenance work orders, and find the best slot to do the maintenance. So for example, if this was 100 hours, we have a window of remaining useful life. We may find the most optimum slot to do any maintenance is 62 hours. And we would then also go and look inside the EAM system against that specific equipment, identifying critical spares, and see if those spares are available. If it is, we will then go and check if there is a work order. If there is currently a work order, we'll check whether it's at the 62-hour point. If not, we can create the work order there, or we can put it in the task list of the work of the maintenance planner to create the work order inside the 62-hour time frame. If there's no work order, then we create it. So as you can see, the same approach, but in this instance a little bit more expansive in terms of being able to create work orders based on three predictive models. One, is it going to fail? Yes. What's the remaining useful life? 100 hours. What's the best maintenance slot? 62 hours. Do we have spares? And through this whole process, we've collected all the data that we need to create really smart and intelligent work orders. Again, the same logic applies for creating actions. So if I create a work order, for example, in here, this is the back end to that. And if I want to map the data by clicking on the arrow, I can now map, as you can see, I can map my data fields coming in to what the integration component expects on the other side. The last thing that I want to do and show you in here is, now that we have this running, so now that we've set this up, I can run this model. And this is a key element of XMPro. It's not just to have a visual model, but how do you execute the model? How do you now run it and push the data through? And in this example, what you'll see is it starts the different services, and if the service starts successfully, it will turn green. If there's a challenge or a problem with any of the services, don't start up or doesn't function properly, the blocks will turn red instead of the green that you see here. And that'll give you what the current health status is. What you see now is a system where it actually pumps the data through. So it reads the information from all of this, combines the information, and run the predictive models and create the work orders on the back end side. So let me stop this. And again, it now stops all the underlying services. This could be deployed in a hybrid environment. So this could be run on premise, this part could be run on the cloud, and this part could be run back on premise. It's a key deployment benefit of using XMPro, is that not all your data needs to reside on premise, not all your data needs to reside in the cloud. You can construct these so that the pub-sub model, the publication of this one, where I publish and where this one subscribe, is dictated by the XMPro orchestration engine. Very powerful approach and feature. So with that, it concludes the overview of how XMPro can set up real-time data listening capability, and how it can create actions based on the analytics that you apply to it.